Today I'm going to introduce one of Ramanujan's many achievements, the Ramanujan Summation. Let's start with the conclusion. The sum of all natural numbers is negative 112. Strange, isn't it? 1 plus 2 is 3, 1 plus 2 plus 3 is 6, and if you add 1 through 10, you get 55. It seems self-evident that if you add natural numbers together, you'll keep getting bigger and bigger natural numbers. But the idea of a negative sum of natural numbers, especially in fractional form, doesn't usually make sense. First, let's imagine an infinite series of 1 minus 1, then 1 plus 1, then 1 minus 1 again, ad infinitum. It oscillates discretely, repeating 4 ones and zeros. Let's call it S1. It will have a value of 0 when added to an even number, and 1 when added to an odd number. Now let's subtract this value from 1. You can see that subtracting it from 1 doesn't change its shape at all, so it becomes S1 itself. To summarize, the value of S1 is 1/2. You could also say that the expectation value is 1/2 because we're going through ones and zeros infinitely. It doesn't converge to a specific value, but it goes to infinity, so let's just take it as 1/2. So let's create the next series. Let's call it S2, and we'll use the same math that we used to find S1. We're going to use the method of adding or subtracting something so that it becomes itself. Let's add 0 to S2. Now that we've added 0, its value doesn't change. It's still S2. Now let's add these two values together. 1 and 0 are added. Negative 2 and 1 are added. 3 and negative 2 are added. If we keep repeating this, we'll see that 1 plus 1 minus 1 plus 1 repeats to infinity. That's right, it's going to be the same value as S1. 2 times S2 is S1, so of course the value of S2 is going to be 1/4, which is half of S1. Now we are ready to find the sum of all the natural numbers. We'll refer to the sum of all natural numbers as S. Let's rewrite it in a slightly creative way, but with the same principle. Let's subtract S2 from the sum of all the natural numbers we found earlier. The first term is 1 to 1 when subtracted from each other, so it's 0. The third term is also 0 when 3 is subtracted from 3. In this way, all the odd terms are 0 and eliminated. The opposite is true for even terms. 2 minus 2 is 2 plus 2, which is 4. 4 is 8. In this way, we can see that all even terms are multiples of 4. Let's tie them to 4. The parentheses become S again. Now we can clean up this simple expression. This gives us a simple final formula. Solving it, we get negative 1/12. We've taken something so easy to add and subtract and come up with a result that is completely counterintuitive. This result seems to be strange. There's a secret here. To add up all the sums of the natural numbers, we use the concepts of 0 and infinity, which are hard to know intuitively. When will the universe end? When did it begin? What came before the beginning? The concepts of 0, infinity, and limit are the scientific equivalents of these questions. If we can't answer these questions, science still doesn't have a clear answer to these questions. May it be arrogant to think we knew the concepts of 0 and infinity. In fact, Ramanujan Summation is already applied in many places in science. Quantum field theory and string theory both employ Ramanujan Summation. Next time I'll introduce a more strict proof, which you can understand if you only know general differentiation. What we've shown today is just a small part of it. Today's expression can be expanded, and it can also be expressed as a general expression. To understand general expressions, you need to understand the Euler-Maclaurin summation formula Bernoulli numbers. Let's not think about it now. Did you enjoy this? If you find any errors, please leave them in the comments. If you enjoyed this, please like and subscribe.
Subscribe it.